Welcome to my YouTube channel. Today we would look at hypothesis testing using R. We would look at an example, or should I say a problem from a manufacturing company that does toothpaste. Then we'll walk our way through the different steps in doing hypothesis testing. And then we'd look at how to calculate the confidence interval, and then finalize it with some business interpretation for this company that has given us this example. I would go ahead with reading the question first and trying to explain some things in the question in order for you all to understand what we're being asked to analyze in this question. So the question says, the production line for Glow toothpaste is designed to fill tubes with a mean weight of 6 ounces. Periodically, a sample of 30 tubes will be selected to check the filling process. Quality assurance procedures call for the continuation of the filling process if the sample results are consistent with the assumption that the mean filling weight for the population of toothpaste tubes is 6 ounces. Otherwise, the process will be adjusted. So taking a minute to just understand the question we have just read. We can see that we're dealing with a manufacturing company that has a production line that makes Glow toothpaste, right? From their previous production, we also discovered that there's a mean weight for filling each of the toothpaste tube, and it has to be 6 ounces, right? As the question states here. And then as part of their quality assurance procedure, every time, which we can understand by this word that says periodically, the company takes takes a sample of 30 tubes, right, to check if it is meeting that mean weight requirement of 6 ounces, right? So now, in the second paragraph, or in the second sentence, it says, assume that a sample of 30 toothpaste tubes provides a sample mean of 6.1 ounce. The population standard deviation is believed to be 0.2 ounce. Right, so here you can see that we're given the sample mean, and from historical data, we've been given the population standard deviation to be 0.2 ounce. So this here lets us know that our population standard deviation is known. So when doing the hypothesis testing, we're going to be using the normal distribution equation to solve this problem, right? So our first question says, perform a hypothesis test, and we're given the significance level, which is 5%, or you can say 0.05, or you can say 95, right? To help determine whether the filling process should continue operating or be stopped and corrected, right? Then the second question says, compute a 95% confidence interval for the population mean. Does it support your conclusion? So we'll go ahead and start with the first question, which is to perform a hypothesis test. And we'll do all of this in R. So please make sure you follow along as I do the coding on R. All right, so I have my R screen or my R software open up here. So the first thing I like to do is to list out all the parameters we will be working with, right? I'm basically looking at the question and just extracting all of those parameters. I think this second sentence gives us a lot, right? We see that the sample size is 30. We also see that the sample mean is 6.1 ounce. And we see that the population standard deviation is 0.2 ounce. And then also we see our level of significance, which is 5%. All right, so those are different parameters we need to extract from the problem. And then lastly, there's one parameter that we're missing as well. We also see the mean filling weight for the population, right? Which is like the population mean, mu, right? It's also 6 ounce. All right, so I think now we have all of them. So let's put all of that in R. So N is 30, right? Which is our sample size, right? Then X bar, which is the sample mean, was 6.1. And then sigma was 0.2 ounces. That is the population standard deviation. And then mu was 6, which is the population mean, right? We could also refer to it as the hypothesized population mean. So please take note of that. And then finally, our alpha, right, which is our significance level, was 0.05. So we can say 5% confidence, confidence level. All right, so now we have all of those parameters listed out, right? You would see how all of that would play in when we get to the test statistics, right? So the next thing we want to do is to state our null and alternate hypothesis, right? So null and alternate state the null and alternate hypothesis, right? So we go back to the question. It says quality assurance procedures call for the continuation of the filling process if the sample results are consistent with the assumption that the mean filling weight for the population of toothpaste tubes is 6 ounces. Otherwise, the process will be adjusted, right? Now, keep that statement in your thought. And then the first question says, perform a hypothesis test at the 0.05 level of significance to help determine whether the filling process should continue operating or be stopped and corrected, right? So the first statement here, right, in accordance with the second, or with the statement from the first question, lets us know that we're not looking at if the process is greater than 6 ounces or if it's less than 6 ounces, right? We're looking at something that must be equal to 6 ounces or not equal to 6 ounces, right? Especially when you look at this part, right? It just lets us know that the population of toothpaste is 6 ounces, right? And then here, to help determine whether the filling process should continue operating or be stopped and corrected, right? So that gives us a sense of what our null and alternate hypothesis will be like. So I often advise my students to start with the alternate, right? So in this case, mu would be not equal to 6, right? And then for the null, mu would be equal to 6, right? So that's basically how you set that up, that the population mean filling weight, right, for the toothpaste tubes is not equal to 6 ounces, right? That's what HA means. And then for HO, which is the null, means that the population mean filling weight for the toothpaste tubes is equal to 6 ounces, right? So that's how we set that up. So looking at this, right, you can infer that this is a two-tailed test, right? This is a two-tailed test. So If you have it as a less than, it's a one-tailed test for the lower side. If you have it as greater than, it's a one-tailed test for the upper side. So just some hints for you to take note of. So let's continue. So now we want to solve part A, which is to perform the hypothesis testing, right? So we will just look at the test statistics. So because we know that the population standard deviation is known, we use the Z equation, or should I say the Z statistics. So Z stats, and this is the equation for it, which is X bar minus mu divided by sigma over square root of n, right? So, X bar is our sample mean, mu is our population mean, sigma is our population standard deviation, and then we have n, which is our sample size. So basically, if you call out Z stat, right, this would basically spit out the result. So I am going to basically run my code from lines number 4 all the way to line number 16. All right, so I have all my parameters loaded into R, and you can see them in the global environment. And now you can see my Z stat as well, right? When I use that the equation I have in line number 15. And basically my result comes out for my Z stat. It comes out to be 2.74 if we round to 2 decimal places, 2.74, right? So that's my result. Now we want to compute the p-value. So because this is two-tailed, we'll use the two-tailed p-value equation. So basically 1 minus the probability of the Z stat, and then you multiply that by 2 because we're looking at two-tailed, right? So I'm just then we'll spit out the result for the p-value. I'm just also going to type it there so everyone can see it. All right, so my p-value comes out to be 0.00, right? So yeah, 0.006, right? Which if we approximate to just 2 decimal places, we could say 0.01, right? 0.01, that's what our p-value would end up to be. But then the question says we should perform that hypothesis test, right? So the next thing we have to do is to determine if do we reject the null or do we do not reject the null hypothesis, right? So I'm just going to write a very simple if else function to help us with that. So reject HO if your p-value is less than or equal to alpha, right? That's when you reject HO. So let's say if p-value is less than or equal to alpha, so we say print, we reject HO, right? Else print do not reject HO. And then I'm just going to say that interpretation. I'll come back to that. All right. So now let's run line number 22 to 27. So you could see it here. It says we reject HO, right? So when you say we reject HO, basically what we mean is that the alternate hypothesis, right, this one is true and this is false, right? So that basically lets us know that the population mean filling weight of the toothpaste tube is not equal to 6 ounces, right? So that's basically what it's letting us know. So we can say that there is sufficient statistical evidence to infer that HA, which is the alternate hypothesis, is true. So that's what it is. So that basically answers part A, right? So let's look at part B now. So part B is asking us to compute the 95% confidence interval for the population mean, right? So I always see the confidence interval as some sort of check to help us determine if this result we got here that says we reject H naught is actually valid or not, right? If it's correct or not. Let me use the word correct instead of valid, right? So basically, if the confidence interval contains the hypothesized value, right, we say do not reject, right? Otherwise, we say reject HO, right? So that's basically how we would interpret the results from confidence interval with regards to the hypothesis testing that we just did, right? So let's see if that would be the case. So the first thing we want to do here is to calculate the standard error, right? Because remember, your confidence interval is the point estimate plus or minus the margin of error, right? And the margin of error is split into two. You have the critical value and the standard error. So the first thing we want to do now is to calculate the standard error, right? Then we'd multiply that with the critical value, right? And then we do the plus or minus point estimate. So let's calculate the standard error first. I'm just going to run this. So your standard error should give you 0.04. We stay with our 2 decimal places when we round it. And then the next thing we want to do is to calculate the Z critical value, right? So So Z critical for 95% confidence level is 1.96, if you remember that. You can also look at that from the Z distribution table. And now we calculate the margin of error. Which is the Z-score multiplied by the standard error. This. So our margin of error is 0.07. Okay, that's our margin of error. And then finally calculate the 95% confidence interval. So I could just say lower bound, right, which is LB. Would be X bar minus the margin of error. And then the upper bound, which is UB, is X bar plus margin of error. So I want to make sure we round our answers to 2 decimal places. So this here helps us to round it, the round function. And then all I would just do is put the result down here. So let's run this last part. Sweet. So you can see that our lower bound is 6.03 and upper bound is 6.17, right? You can see that there. And then, let me just put this up here, right? So I can have my interpretation down here. So for the business interpretation, right, we can basically see that when you, if you remember, our population mean was 6, our hypothesized mean was 6, right? So if you look in here, you can see that 6 does not fall within that interval of 6.0 to 6.17. It is outside the interval, right? Hence, our conclusion from the hypothesis testing that we reject HO was actually correct, right? So I can just say the confidence interval analysis proves that our hypothesis, our hypothesis is correct, and hypothesized population mean is not bad. So that's basically how we would answer the question. So all right, so just to kind of provide that final business conclusion, right? So since we stated that there is sufficient statistical evidence to infer that HA is true, right? Which means that the population mean filling weight is not equal to 6. And remember here, it says to help determine whether the filling process should continue operating or be stopped and corrected, right? So we would be recommending to this manufacturing company that their filling process should be stopped, right? And then they should correct the filling process or whatever operations they have to go through to fill each of those tubes. They have to correct the process to make sure that they are meeting that mean filling weight of 6 ounces and it's not going above the 6 ounces. So that's basically how you will provide your recommendation to the company. So I hope this was helpful. Thank you so much for watching the video. Please like it and also subscribe to our channel. Thank you.